Now we will consider the load file. From build tower we will build the tower, and load tower we will consider the loading values. These lines are only for illustrative purpose, so a dollar sign will indicate that it will not be considered in the analysis or anything else. Main thing is parameters. Angle is 0, you can put anything here, and design code is BS8100. You can put EIA or TIA 22F or G. So if your country don't have ICE, then you can delete it or keep it values 0. L top means the tower is at up to which level. This is a rooftop tower, and it's has been built on a 6-story building. That's why L top is 18 meter. PSFV versus certificate of velocity 1.15. This has been illustrated in the code or the spec of the vendor. Our vendor has been given that they need the PSFM 1.15 for wind speed. That's why we have given here PSFV 1.5, and partiality factor for material is 1.1. It has been given also in the spec of the vendor, 1.1 for design strength, and 1.1 for load combination and 0.9 for load combination. We will discuss this later. Now main is PSMV is 1.15 and PSFM 1.1. Normally these values are given in the spec of the vendor who are making the tower or who are purchasing the tower. VV is 52 mean. This is the meter per second wind speed, and 3-second gust wind speed. As BS code wind speed is 3-second gust wind speed. TI 222F wind speed is fastest mile wind speed, but TI 222G is again 3-second gust wind speed. So hope you know that. In this case it is 3-second gust speed and 52 meter per second mean. Overlap once means it will consider the overlap. It will reject the overlapping part of a member. Eventually finally it will reduce the wind load. So we always sure make this 1. If we make this 0, then it will not consider overlapping members. In BS code, Terrain is important thing. Angle 0, no problem. TCAT means terrain category. There are 5 terrain category in BS code, 1, 2, 3, 4, 5. We are considering terrain category 5, which is the lowest, which will give lowest wind speed. If we give 4, then it will give a higher speed than 5. KD directional factor 1, and other values you can give 0, no problem. All these values have been discussed in the HEL file. Loads. By writing these loads, you are saying that you are now considered load. Case number 100. This is description of the load, and if you write DL, then it will consider dead load. Case number 200. This is the description of the load, and if you write WL, it will consider that you are saying this is a wind load, and angle 0, no ice cross. In this case you will make the primary load case, and you can make as many as load case considering the wind speed and their direction. The load combination for member design and base plate design, and you can see that dead load has been multiplied with 1.1, and for compression member, and for tension dead load has been multiplied by 0.9. This has been said here, the 1.1 for dead load for compression and 0.9 for dead load uplift. So this load combination and this load combination are almost same, except this 0.9 and 1.1. And support reaction for unfactored load combination for foundation design or any other case, we have made the other loading values. Remember that for dead load it will be multiplied by 0.76. 0.76 is nothing but 1 by PSMV square, 0.76. And for deflection check, all load compression will be multiplied by 1. Ancillaries, the vendor will tell you about these ancillaries. Linear ancillaries means our ladder and feeder line. Linear ancillaries, ladder and feeder lines. We are using a plain ladder, that's why you have taken the value P ladder from PMS lean. It's a ladder. If you want to see the wind load acting on the ladder, we have to go to the PMS lean. We'll go it afterwards. And feeder, we are considering that 20 millimeter diameter feeder and number 2, and they will be start from 0 to 21 meter of the height, and ladder will be considered from 0 meter height to 20 meter height of the tower. Large PNs microwave dish, these values will be given from the vendor. Here our vendor has given that they need 6 nong GSM antenna at 1 meter below the top of the tower. So 6 nong GSM, they have asked for GSM 2.3 meter length GSM. So 6 GSM, 1 2 3 4 5 6 GSM at 22 meter. The tower is 23 meter, and they have asked for 1 meter below the top of the tower, that's why it is 22 meter. And these are other values: 2 nos 1.2, 2 number 1.2 microwave dish, solid dish. So 1.2 dish are actually 4 feet diameter dish. So four divided 3.28 is 1.2. So standard high performance dish, 4, and we have given a position of the dish where it will be attached. In this case, you see that we have attached the dish a bit apart from the tower. That's why you have given these values. And the vendor also asked for 2 number 0.6 meter dish at 2 meter below, another 2 number 0.6 meter dish from 3 meter below. All these dish has been given here, and the wind force acting on the dish are calculated from this reference of PNs. Now we will go to PNs, ancillary library, program ends, PNs, program ends, and our dish is standard high performance. These are dished: 1.2 meter dish, 0.6 meter dish. This is the shielded antenna, and diameter is 0.6 meter, diameter is 1.2 meter. Mass, this is an ASF. You can also find this AF and ASF from the antenna supplier like Catherine Andrew or any company. And you can make your own dish and give a unique name here and put the diameter, mass, AF, ASF from the antenna catalog of the supplier, and you can use that antenna in your analysis. And if you go through this PNs, then you see there are many types of antennas: shielded, with radome, without radome, standard antenna. So if your vendor asks for standard antenna, you will then give this antenna. If your vendor asks for radome antenna, then you will give this. We normally give shielded antenna, because shielded antenna gives highest value for winds. That's why we consider the highest wind speed and use shielded antenna. And there are many types of antenna given here. If you give for GSM antenna, GSM antenna is given here, and you can make your own GSM antenna by the vendor or supplier of the antenna. We are using GSM 2.3, a cylindric antenna. Its length is 2.3 meter, mass 20 kg, AF, ASF. This value is given here. So this is our this conclusion of our loading of antenna. So linear ancillaries means the ladder and feeder, and large ancillaries means the dishes and end.